So we saw in detail how to do the first part of this question. Now, what about the second part? In the second part, it asks you how much time has elapsed in moving from the initial position to this position 30.5 meters away. And you're going to find an equation that you can use which contains time because you want to solve for time. So you're going to look at your list of kinematic equations and choose one of them where you should have just one unknown, which is time. Okay, so if we choose v equals v0 plus at, we do know the initial velocity, we know the acceleration, we can solve for time, and we know the final velocity. So we could indeed use this. Okay, if we plug in the numbers, we know the final velocity is 17.5, the initial velocity is 0, the acceleration is 5 meters per second squared, so we just need to solve for t. That's 17.5 divided by 5. It's going to give us 3.5 seconds. So pretty straightforward. If you happen to choose a wrong equation, you can abandon it and choose another equation and try. So when you are choosing your equation, you always want to check that you have just one unknown, which is time, in your equation. Yeah? And then you'll be able to solve for it by substituting the right values. In part C, which is a little tricky, I'm going to talk you through this. Calculate the average velocity in two different ways. So one way to find average velocity is if you know two different velocities, you add them together, you divide by 2, you're going to get an average of anything, right? So therefore, you can also get an average of velocity. That's this method here. When we write a bar on top of a letter, it means it's an average. So this is the average velocity. Since we have 2, we add them together, divide by 2. If you have 3 velocities, you'd add them together, divide by 3. Just taking an average or a mean. We know the initial velocity, we know the final velocity, which are these two numbers. We divide by 2, we're going to get 8.75, and that's in meters per second. So this is the average velocity. Another way of finding velocity, because it asks you for two different ways, we can take the definition of average velocity. So that was displacement with time. So delta x over delta t, open out delta x as xf minus xi, delta t as tf minus ti, t initial is 0, t final is the 3.5 seconds that you just got, right? The initial position is 0, because that's where we're setting our origin. The final position is at 30.5 meters. So we just need to divide one by the other, and that gives us 8.71 meters per second. Note the discrepancy in the last place. So in the second decimal place, you have uncertainty. Remember, we talked about uncertainty in chapter 1. So we often find when we do mathematical solutions, numerical solutions, that we might have a slightly different number in the last place. And that is often due to, dependent on when you average out or round it off, okay? So there are several ways of rounding, whether you round at every step and you see significant number of significant figures at every step, or you do it at the very end. These could be different things. Typically, we will fully solve a numerical problem and then consider significant figures and round off, okay? But this kind of variation in the last decimal place would be allowed for. Okay, so that would not be considered wrong. Either of these would be a right answer so long as you got to 8.7. Okay? And we're going to just talk in general about how to solve problems. So in your homework, you will find other problems to solve using kinematic equations. You're going to read the problem. Right? Try to understand the problem, make a rough sketch. It doesn't have to be a beautiful sketch. It just needs to be a diagram or a sketch where you're going to label everything as much as possible. So remember, the first thing you need to do is choose an origin and coordinate system, right? You need to define in a one-dimensional system, where is your one dimension? Is it left, right, or is it up, down? You're going to define your initial and final points. The initial point will often be the origin. Okay, so you might want to set your origin at that starting position, and that the ending position that the question is talking about would then be your chosen final point. You're going to indicate the positive direction for velocity and accelerations. By convention, if you take positive to the right, you will find it easier. That's the convention that we follow. both for velocity, position, and acceleration. Okay. You want to write as much information as you can on the sketch, such as your initial velocity, your final velocity, just like I showed you in the example, the part A of the group work. You're also going to mark on there what is not known. So it might be that you're asked for time, it might be that you're asked for that final velocity. Whatever is unknown and you're asked for, you want to write it with a question mark. Then you're going to find an equation or some connection between what is unknown and what is known. So this is often the hardest part. This is going to be the key to solving your problem. So you might need to look at your notes, look at the kinematic equations, and choose something where that unknown exists in the equation and is related to some known quantities. Okay? So always remember, if there's one unknown, you need one equation. If there are two unknowns, you need two equations. If there are three unknowns you're asked for, you need three equations. Okay? So choose the appropriate kinematic equation. You can have your list of kinematic equations with you, both in the test and the final exam. I will let you have your equations with you, so you don't need to memorize them. But by repeatedly doing questions, you should get so familiar with them that you don't really need that piece of paper. Okay, that's what you're aiming for. Once you've written that equation, you want to then solve for the unknown. So you want to maybe rearrange your equation so that your unknown, let's say it was time, is the only quantity on the left-hand side and everything else is to the right. Then you want to substitute the values that are known, solve it. You can use a calculator, okay, typically. You'll get some number out from your calculator. You need to then think about how many significant figures you want to report that to. That's going to be your result, okay? And once you have the result, you want to add units to it, and then you're going to think about it, reread the question, see, does this make sense, right? So you're going to estimate and compare units, etc., to see whether what's given to you in the question, what your result is, do they match up, okay? So if you get a great discrepancy, it seems to you that this does not look like the right number or the right value, or I forgot to write units, this is the point at which you go back and check. And then you're done.